Hi again, everyone. Dr. Tom McNamara here for our course in college algebra. We are going to continue talking about logarithmic functions. In this video, we are going to discuss some properties of the logarithmic function. In particular, after watching this, you should understand the product, quotient, and power rules for logs and understand how those are related to the familiar rules for exponents that we already know. Once you know the product, quotient, and power rules, you should be able to break apart and combine logarithmic expressions. So let's get right into it. So, you're probably fairly familiar with the rules for exponents. For example, if I have two powers of the same base multiplied together, I should add the exponents. Okay, and that's fairly straightforward, right? If I had 4 to the 2 times 4 to the 5, that would be equal to 4 to the 7, right? Because if I had 2 factors of 4, and then another 5 factors of 4 in this part, then I have a total of 7 factors altogether, okay? So, multiplying, add the exponents. Well, what do logs tell us? Logs tell us exponents. So, the corresponding rule for logs says that, all right, you want to know what exponent should I use for this product? Well, you should use the sum of the exponents that you use for each individual part. Okay, since the log tells you the exponent, each corresponding rule for exponents give rise to a rule for logs. Okay, so what power should we have on the product? Well, you add the powers that you need for each individual part. You take the power from this plus the power from this. And that's exactly what we're saying over here. What exponent should I use on B to hit this target? Well, I use the exponent for this part plus the exponent for this part. Similarly, we have a rule for exponents that goes like this. If I take 2 powers and divide, that's equivalent to subtracting the exponents. And that leads to a corresponding rule for logs. Okay, this is saying these two equations are saying the exact same thing. What power do I need on this quotient? Well, you take the difference of the two powers. What power do I need on this quotient? You take the power you needed for the top and subtract the power that you needed for the bottom. Okay, so we have the product rule for logs. We know what logs do to products. They turn them into addition. We have the quotient rule for logs. They turn them into subtraction. And we have the power rule for logs coming from this. Okay, we know this rule for exponents as well. If I raise a power to a power, I should multiply the exponents. Okay, so log base b of m to the n. What power should I use for this? Well, I take this new power and multiply by the power I needed to get big M. Okay? So we have the product rule for logs, the quotient rule for logs, and the power rule for logs. And all of those come from the familiar rules for exponents because logs tell us exponents. So logs follow the same rules that exponents follow. Okay? A couple quick examples where we'll use these to break things up and, more importantly, put things together. So in this example, I'll give you an expression that has just a single log, and we'll break it up into a sum or difference of logs. Okay, let's do something like this. Log of x times y. Let's give a specific base. Let's say log base 3 of x times y. Okay. Straightforward application of the product rule. That's log base 3 of x plus log base 3 of y. Okay, let's do a little more complicated example. Let's do log base 3 of x over x plus 1. Let's change the base even. It doesn't always have to be base 3. Let's go log base 7. Doesn't matter what the base is. The same rules apply to all log functions. Okay, so I'm looking at a quotient here. So I apply the quotient rule. Log base 7 of x minus log base 7 of x plus 1. Now, it's important to note that this last expression I just wrote down, this cannot be broken up. Okay? We have the product rule, we have the quotient rule, we have the power rule. There is no sum rule for logs. Logs do not break up over addition. They break up over multiplication. These guys aren't multiplied, so we have to leave it as is. Let's do one that has multiple rules, all in one. Let's do log base 2 of x power 3 times y over z power 5. Okay, so I got a product, I got a quotient, I got powers. We're going to need to use all the rules. Okay, here's what I would do first. I would do log base 2 of x cubed y minus log base 2 of z to the 5th. All right? So notice I did the quotient first. And then I would break this up here. 3 log base 2 of x plus log base 2 of y minus 5 log base 2 of z. Okay, so there are a few things I want to point out here. Going from here to here, I bet you can see what I did, right? Notice the 5 is no longer a power on z. I brought it out front. And that was an application of the power rule for logs. Now over here, I had things multiplied. Okay, log of x cubed times y. So I broke that up into log base 2 of x cubed plus log base 2 of y. And then when I had log base 2 of x cubed, I applied the power rule again, getting the 3 out here. Okay, notice this does not have a 3 because y was not raised to the third power. Only x was raised to the third power. That's why the 3 is over here, but not over here. And that's also why I had to break it up as a product first. Okay, so you almost have to do these guys in like reverse order of operations. I dealt with the division, then I dealt with the product, and the last thing I did was to deal with the exponents. Okay, so these examples were taking something written as a single log and breaking it up into multiple logs. And that can be useful if you know the parts. But it's even more useful to go the other way. And we'll see a lot of examples of that in subsequent videos when we start to solve exponential and log equations. combine into a single log. Okay, combine into a single log. Let's try this. Ln of x plus ln of x plus 1. And of course we remember that's a special notation there. Ln x is log base e of x, and if you just see log without any subscript, that is indicating log base 10 of x. Okay, so here we have log base e. We see that a lot when we deal with continuously compounded interest or continuous growth. Okay, so I see logs added together. So what we're going to do is we're looking at our three rules for logs. We have the product rule, we have the quotient rule, we have the power rule. Which of those involve logs added together? If you check back, you'll see it was the product rule that had logs added together. So, we got this. Okay, now the key thing is that those rules work both ways. If you have a product, if you have log of a product, you can break it up. Sum of logs. If you have sum of logs, you could combine it to log of a product. Equivalently, you could say this, ln of x squared plus x. I just distributed there. Okay? Let's do one more example of combining. Let's something like this. Let's take log base 3 of x, log base 3 of x minus 1/2 log base 3 of 2x minus 5. Okay, now, a little bit of a sticky point here. I can't combine until this is out of the way. Okay, so first thing to do is get that coefficient out of the way. And heck, I'm going to do this. Okay, why am I doing that? Well, little side thingy over here. The power rule for logs says I can take this 1/2 and put it up as a power. So I got 1/2 power. And we know what 1/2 power is. 1/2 power is equivalent to the square root. Okay? Now, once that coefficient is out of the way, now I can combine them into a single log. Log base 3 of x over square root 2x minus 5. Okay, close parentheses. So remember, the quotient rule for logs was the rule that involved subtraction. Okay? So we got three important rules for logs. The product rule, the quotient rule, and the power rule. You can use them to break up a single log into multiple logs if you need to, or you can use it to take an expression that has a bunch of logs and combine them all into a single expression. And as I said, we'll find this version quite a bit more useful in our work.